Alright, here we go with the problem about morphisms. Homomorphisms, epimorphisms. Remember, epimorphism is surjective homomorphism. So, for the first part, let U and R be a unit, and eta from R to R prime a homomorphism. We know U inverse is in R because U is a unit. Now eta U inverse equals eta of U inverse, which is just eta of 1, and this is a homomorphism, so this is 1 prime. Then going the other way, this is eta of 1, and this is eta U inverse U, which is eta U inverse eta U. So what does this mean? This means eta U is a unit in R prime with inverse given by eta of U inverse. Now, does this imply that eta is an epimorphism of the group of units onto the group of units of R prime? So you might think this might be true, and so you start proving it or trying to prove it, and it might not work. And so then you think, oh, well, maybe it's not true, and you try to come up with a counterexample. And one of the first things that you might think of might be the following, which ends up to be a counterexample. Next, let eta be the map from Z to Z mod 3 be given by, you send eta of k to the modulo class in Z mod 3. Eta is clearly an epimorphism because we know that's we've talked about this. We're just modding out by an ideal, and so yeah, we talked about this a bunch in the class. And of course, like, just taking 0, 1, and 2 will give you all of Z mod the ideal generated by 3, and so that should be, oh wait, that's, well, anyways, it's clearly an epimorphism. 1 is the only unit of Z. No, that's not true, because minus 1 is also plus and minus 1 are the only units of Z. And what is eta of 1? Eta of 1 is just 1. And so your eta of minus 1 is what? This will give us 0. Won't be 0 bar. It'll have to be 2 bar. See here. Oh, this is actually a problem. This should be right. Maybe 3 isn't enough. Alright, so I figured out my issue. Having Zmod 3 wasn't enough. We have to have Zmod 5. And so what happens is, as I said before, plus and minus 1 are the only units of Z, and let's see, your eta of 1 is 1 bar, and eta of minus 1, well, let's see, your negative 1 mod 5 would give you 4, right, because you take 0, and then you go down 1 from 0, and you go back around to 4, so it's 4 bar, and so so the image of the units of R are the modulo classes 1 bar and 4 bar, but if you look, you have 2 bar times 3 bar is 6 bar, which in this ring is the same as 1 bar, and so you have 2 and 3, which are units in Z mod the ideal 5, but they are not in the image of the units Two and 3 are units which are not in the image of the units of Z under this map eta. And so, therefore, this tells us that there are this is not a surjection. So the map eta does not surject the units of R onto the units of R prime, and so therefore we have a counterexample for the claim, or for the second part where it says, does this imply that eta is an epimorphism, blah blah blah. No, it does not, because here's a counterexample. And so there we go. This completes our proof.